We're back with live sound reinforcement. Let's get right into this segment on tuning the PA. Oh, you're going to play a music track. I thought we were going to tune the PA.
Well, you got to have a tune if you're going to tune a PA.
Okay. Is there a standard process you use each time you tune the PA?
Yes, it's usually a three-step process. First thing I'm going to do is check the signal flow and all the speaker connections using pink noise. Then I'm going to play a music track, and I'm going to make any adjustments to the EQ and the crossover and compressors if I need to.
Well, why don't we start with the signal chain?
Sure. First thing I'm going to do is I'm going to mute the mains. I'm going to do that right here at the crossover. Then I'm going to play that music track. I'm going to check its input as it comes in here to the console. Then I'm going to send that through the system, checking its signal flow through the EQ, the compressor, and then the crossover.
So Dave, how are the compressors set?
Well, they're set for peak limiting with a threshold of 0 dB and a ratio of 3:1. And this is to protect your speakers from any drastic volume spikes.
Like if the lead vocalist were to drop their mic or the drummer were to smack a tom mic with their stick.
Exactly.
Well, I'll tell you what, why don't we show our viewers how the limiter reacts when that happens. Ready? Drop. Ooh.
Man, that thing lit up like a Christmas tree.
Imagine what that would have done to your main speakers without the limiter. So Dave, we set the compressor up as a limiter. What settings do you use to do that?
Well, if you have a choice, I would set the compressor for a hard knee compression. Then, when your console output is at 0, your limiter should be just kicking in.
So everything looks okay?
Yeah, looks great.
So now on to step 2, you run pink noise.
Yes, I'm going to run pink noise through the system so that I know that all the connections are made correctly to the amps from the crossovers. If you accidentally flip the crossover signals on the return snake at the amps, you could have the signal to the lows patched into the high-end horns. That would blow the horns. So I run pink noise first to verify that everything is connected correctly.
Do you do that in a specific way?
Yes, I always start with the highs, then the mids, then the lows. Because if you're connected incorrectly, it's always better to send high-end signal through a low-end driver than vice versa.
Where's the pink noise coming from?
Pink noise is coming from my RTA, or my real-time analyzer. Pink noise comes out of the RTA, back in my console here at channel 22.
Dave, show us how you use it.
Well, first I'm going to go ahead and turn up the mains, and then I'm going to start at the highs. Then the mids, and then the lows.
Okay, so now we know that the speakers and the signal chain are connected properly at the amps. So it's on to step 3.
Yes, tweaking the system. I'm going to start at the crossover and make any big adjustments that I need, and then I'll fine-tune with the house EQs.
What do you mean by big adjustments?
Well, a crossover subdivides the output from the console into 3 broad frequency ranges: a low range, a mid-range, and a high range. So if you're making any adjustments on the crossover, you're making big frequency adjustments.
Dave, why don't you take us on a guided tour of a crossover?
Sure. Here on the front are 4 controls: the input level control, the crossover frequency control, the response control, and the output control. The input level control allows you to boost the signal coming from your mixer before it reaches the crossover filters. This U here at the 12 o'clock position indicates unity gain, and that's where you should set your input level. These 2 crossover frequency controls allow you to select the crossover points for your 3-way system.
So 2 controls for a 3-way system. That's a little confusing.
Well, what we're doing is we're defining 3 separate ranges from low to high within the 0 to 20 kilohertz spectrum. But you only need 2 knobs to do that. Let's say you set your first crossover frequency control at 250 hertz. This setting of 250 hertz now actually represents 2 settings: the high side of our first range, which is our lows, and the low side of our second range, which is our mids. All the frequencies to the left of this mark will go to the lows, and all the frequencies to the right will go to the mids. To set the high side of our mid-range, which is our second range, we go to the second crossover frequency control. If we set the control here at 2.5 kilohertz, we've now set the high end of the second range, which also becomes the low end for the third range. So our second range now has 250 hertz for its low side and 2.5 kilohertz for its high side. The third range now has its low side at 2.5 kilohertz, and its high side set to all the frequencies above that up to 20 kilohertz. So, we've defined three ranges. Our low range is 0 Hz to 250 Hz. Our second range is 250 Hz to 2.5 kilohertz. And our third range is 2.5 kilohertz to 20 kilohertz.
Dave, can the horns in the system reproduce 20 kilohertz?
No. In reality, it's more like 12 to 16 kilohertz. But that's plenty of top end for a live sound situation.
One more question about the crossover. What's the response control?
The frequency response control allows you to adjust the response shape of the filters at the crossover point.
You better explain that.
Well, where two crossover points meet, for example, between the lows and the mids, the curves overlap. When they do, there's a 6 dB increase in volume, which can affect the sound around that area. We call that a bump. The response control allows you to flatten out the curve at that area. If you set the control at 3 dB, that means the unit will roll off 3 dB from each frequency at the crossover point.
So there's a separate output level control for the lows, the mids, and the highs.
Yes, the output level control controls the output level or volume of each range of frequencies as they go to the power amps.
So how should the power amps be set?
Typically, the power amps should be set to full on and the crossover set to unity. However, in a multi-amp system like this one, you might run the high frequency level output controls on the crossover at a lower setting than the low frequency.
Why is that?
Because horn and compression drivers are far more efficient than cone drivers. About 12 to 20 decibels more efficient. So I like to run the outputs of those at a lower level to compensate.
So what settings are you going to use for these speakers?
250 Hertz for the low, 2.5 kilohertz for the high. I highly recommend using the manufacturer's suggested settings for the speakers in your system, or you could blow your drivers.
Why?
Because if your settings are too high or too low, then you're increasing the frequency range beyond what they're designed to handle.
Okay, how about your output settings?
We'll set the output for the lows, mids, and highs at 0 or unity. We'll set the response control for 3 dB. That way we can smooth out the area where the crossover frequencies overlap.
Dave, would you do this every time you set up the PA?
No. If I'm using the same gear night after night, and the room that we're playing in doesn't have any severe problems like balconies or overhangs, then I just make sure that the settings are where they're supposed to be.
But if the room had real problems, you'd use a crossover?
Yes.
Okay, back to the CD. By the way, how do you have the CD patched into the system here?
Well, the CD output is coming directly into a stereo input on the mixer. Most mixers have 1/4-inch input jacks for line-level equipment. And I also leave the EQ flat.
And you recommend using a familiar piece of music?
Yes. You want a CD track that you've heard 1,000 times before, and you know in your head just how it's supposed to sound.
So you play the CD. What are you listening for?
You're using a CD track as a frame of reference to see how it differs in sound in the room from how you're used to hearing it.
So you listen to see if you have to make any adjustments on the equalizer or crossover?
Yes. First, I listen to it to see if I need to make any crossover adjustments. But usually, I just tweak the house EQ.
What kind of house EQs are you using?
Here I have a BSS 1/3 octave stereo graphic EQ.
Okay, Dave, basically, what's the function of an equalizer?
Essentially, an equalizer is a series of circuits or filters that split the entire audio spectrum into separate bands. This unit, for example, has 31 bands. Behind each slider, there's a circuit that filters out all other frequencies except the one indicated on the slider. This allows you to boost or cut just that frequency. The filter outputs are then recombined to produce a full range output.
So what do you use it for?
I use it to flatten out any hot spots in the room.
The hot spots?
Yes. Every room has its own acoustical properties. Some are good and some are not so good. The crossover and the house EQs are just simply tools that I use to shape the sound that's coming out of the speakers to work within the room's own acoustical environment.
Explain that a little more.
Well, for example, if there's a balcony near the listening area, it can cause a bass trap where you get standing bass waves under the balcony. This could mean lowering the power to the low end. If you have a low ceiling or hard surfaces, you know you're going to have high frequency problems. This may mean you need to reduce the power to the horns. The more rectangular or square the room is, the more issues you're going to have with parallel walls, which cause a reproduction of bass waves as they bounce back and forth between the walls. If you have pillars in the room near the horns, you're going to have problems with high-end dispersion.
Would you use the house EQs to solve these problems or the crossover?
Well, depending upon how bad the problem is, I'd use both. The crossover to make any broad changes, and the house EQ to fine-tune.
Can you give us an example of that?
Well, in a room with hard surfaces where signal bounces around, you know you're going to have high-end problems. That's more of a broadband issue, meaning many frequencies are going to be affected. So you're going to use the crossover output level for the highs to bring down the horns, as opposed to a specific frequency, such as a ring at 8 kilohertz, where you'd simply notch it out with the EQ.
So it's important for a sound engineer to be able to recognize the different frequency ranges.
Yes, because you can solve feedback problems a lot quicker if you know what frequency range is ringing and are able to grab it quickly.
To better help you identify various frequencies, we've recorded 5 seconds of each frequency band on a 1/3 octave fixed frequency EQ. Bear in mind, the type of speaker you're using to hear this program may or may not be able to reproduce the lowest and highest frequencies we've recorded here. A full range speaker would be best suited for hearing the fundamental of each frequency. One thing to remember is that an adjustment of an EQ control will have effects beyond the center frequency you're working with. How far depends on the Q, or the bandwidth of the filter. For example, if you boost 1000 Hertz or 1K, you're also going to pull up 800 to 1200 Hertz to a lesser degree. We'll talk more about the Q later on in the show. Okay, so now back to our music track. We've got a CD in the CD player, and Dave is going to work with the house EQs and that music track to tune the room. Okay, Dave, show us how you do it.
Okay. Yeah, that sounds good.
Show us what you did.
Well, I went ahead and boosted some high end at 6.3K and at 3.15. Now I cut a little mid-range at 500 Hertz and boosted a little low end at 250 Hertz.
Sounds good to you?
Sounds really good.
Well, that just leaves the monitors. So what do you do about that?
Well, I'm going to run some of the same CD track through the monitors to make sure that they're working. I'm going to go to mix 1, and then mix 2. After that, I'm going to go up on stage and put a vocal mic in front of the monitors and ring out the monitors. When I'm done with that, it's time to amplify the band.
Great, Dave. As you can see, tuning a PA system is critical to setting up, and it takes some practice. But as you learn to identify frequency ranges to control feedback and how to use the crossover and house EQs to correct acoustical problems, it'll become a much quicker process. Let's recap what we learned in this section. Step 1 in the process of tuning the PA is checking the signal chain. To do this, first mute the mains. Then patch a CD player into the mixer and adjust the input gain on the channel to an appropriate level. And make sure you're seeing signal at the house compressors. If you don't, check your connections and make sure you're coming out of the mixer into the house EQs, out of the house EQs into the compressors, out of the compressors into the crossovers. To protect the main speakers from volume spikes, set the house compressors for peak limiting with a threshold of 0 dB and a ratio of 3:1. The limiter should trigger when the mixer output goes over 0 VU. Next, stop the CD and turn the mains up. Connect a pink noise generator to a channel on the mixer. On the crossover, unmute the highs, then the mids, then the lows. This verifies that the crossover returns from the front of house are connected to the correct amp inputs and that the amp outputs are connected correctly to the lows, mids, and highs. Once you've confirmed the main speakers are connected correctly, tweak the room using a familiar cut of music. With the mains still up, play the CD and listen carefully. Using the music as your frame of reference, listen for differences in how it sounds in the room with how you know it should sound. Is the track too bassy? Does it have too much high end? Is it lacking punch or fullness? Once you've noticed specific areas that need attention, cut or boost various frequencies on the house EQs until the track sounds closer to how you know it should sound. But be careful not to over-adjust. A good rule of thumb is if you've moved more than 6 faders, you may be doing something wrong. Put the faders back into the null position and begin again. Run some of the CD signal through the monitor aux ends to make sure they're connected properly. Finally, ring out the monitors using a vocal mic on stage. Slowly raise the aux end gain until you hear ringing. Find that frequency on the monitor EQ and lower it just until the ringing subsides. Then raise the aux end gain further and repeat the procedure. Do this until you can raise the gain and get ringing across a range of frequencies, not just one. This indicates you've leveled the monitors. Okay, now that the PA is tuned and ready to go, we can turn our attention to the next step, getting the band amplified. In this upcoming segment, we'll show you how to amplify a typical 4-piece band using mics and direct boxes. We'll also take a close look at how microphones work and which mics are better for live sound reinforcement. Also, we'll pass along some useful tips and techniques about amplifying different kinds of instruments. So stay tuned. We'll be right back with more of live sound reinforcement.